Assalamualaikum warahmatullahi wabarakatuh. Okey, bismillahirrahmanirrahim. Selamat pagi semua. Good morning. Okay, so this is the first class where we start in the very morning, very morning. I not been in this situation for quite a long time because usually my class start 10 o'clock. But this is the first time I start at 8 a.m. The reason why I changed to lecture because of I've mentioned in last class, which is your laboratory cannot start yet because we need to have some kind of theories before we can start with learning. For your information, for laboratories, for lab we're going to use National Instrument hardware, NI. Have you heard about National Instrument? NI. The model is 6008. We will use many kinds of sensors, strain gauge, piezoelectric sensors, and a lot of sensors. We're going to study the theory about each sensors, and then we're going to implement during the laboratory. And at the end, I will give you some kind of projects for the use of all of these sensors. Okay, in the previous class, we stopped at this page, desirable characteristic. I think I need to remind you about the our basic functional elements. I frequently stress to the students about the basic functional elements. We have 4 of them, which is the sensor elements. We have the signal conditioning elements. We have the signal processing elements, and at the end we have display elements. Each of these elements is very crucial, very important in a measurement system. In any measurement system, all these things must have in the system. As simple as thermometer, they also have these blocks, basic functional block. The only thing is maybe the signal processing signal processing, maybe some of these system don't have that one because sometimes it's not required because of it's not digital. For example, the one that you have in I frequently use the same example, the pressure pump, okay, that you have in any petrol station. The pump actually is using a manual mechanical pressure. So thermometer, mechanical, and I think all the pressure sensor, pressure gauge, pressure transducer, most of them using just mechanical. If you see in plants, chemical plants, oil and gas plants, frequently they use a mechanical pressure transducer, which is they're showing in terms of needle, using a needle as a display. Because of maybe I don't know, maybe because it's cheaper, or maybe because of they don't have, or maybe because of each parts of measuring points though, they need to have a lot of sensors. So if you use electronic sensors, maybe it's more expensive, and also it is given the same information. If you use needle or if you use digital value, the same information you got. So that's why in industry they frequently use C in terms of cost lah. But for automotive, because they are more to electronics, so they have electronic sensor lah. So they need to have a signal processing element. Okay, so there's difference between in the industries to industries lah. Oil and gas, they are rich industries actually, but they don't want to invest a lot of money to these sensors. But for the automotive, I don't know, it's actually relative lah kan, expensive or not. But because of automotive, they're dealing with the small piece of equipment, so they're looking for the electronic sensors. Okay, that's a different lah. And then but the thing, how how different the size, they must have that 4 basic elements. We have discussed in the previous class about the sensors. Okay, now we move to the second one, the second element, which is the signal conditioning. For the signal conditionings, basically you just try to make sure that the signal come out from the sensors can be read by the next stage. So the next stage is the signal processing lah. So before go to the signal processing, they need to condition the signal. If the signal have very low voltage, we need to amplify. If there is a lot of noise, we need to filter the noise. There is 3 kind of filtering. Nanti kita akan tengok, we will see after this. Mechanical, electronics, and also the pneumatic filter. But for the signal conditioning, I believe there is 4 main things to be done. I think I need to use 3 only. Three important things. Which is the first is signal amplification or attenuation. Signal attenuation or amplification. Second one is signal filtering, and the third one is converting the signal to the digital. Okay, and the other one is integration. Integration is maybe just integrate with something else, but I think that one advanced. We go to the basic one lah. So the basic one is the first 3 is attenuation and amplification, filtering, and A to D, analog to digital conversion. So whatever methods whatever things that we use is actually to make sure that the signal being conditioned, being prepared, so that it can go to the next process. Okay. So actually this is actually the example. Okay, for the amplification, the easiest one is the microphone lah. You need to have an amplifier, and then filtering. Okay, filtering filtering also can be done in a few ways, mechanical and also in electronics ways. Same with the amplifier. Amplifier also can be done using mechanical or electronics lah, saya rasa. Okay, this is about the signal amplification. 2, either we amplify or we attenuate. Usually we see an amplifier kan. Biasa kita amplify lah. Usually we amplify the signal because the sensors, the smaller the sensors, they require very small voltage, very little voltage. Of course, if the signal need to have a very small voltage, it also give very small voltage lah. But the thing is, the voltage varies. The voltage varies depend on the parameter that we want to measure. But the thing is very small amount, so that small amount cannot be read by our equipment. So we need to amplify. Either we amplify with external equipment, or we amplify using the software, electronic digital software. Okay, so same with the attenuation. Just opposite to amplification. We reduce the signal to make sure that tapi aslinya attenuation is easy, because whenever we attenuate the signal, it will be only affect the amplitude. But when we amplify, usually when we amplify the signal, the problem is we also amplify the noise. That's a problem. So either we make sure that we know the noise, okay, or we amplify the source of the sound. For example, like say in this room, I'm using the microphone. The microphone only capture my voice, but at the same time we have a sound around the room, which is from the aircon, which is maybe some person doing work outside. So they giving a lot of noise today, in fact to the microphone. So what I do is I only amplify my voice to the certain level, so that the ratio between my voice to the surrounding noise have a lot of different. We call it SNR, signal to noise ratio. We increase the signal to noise ratio, and then we can have acceptable information. So this is the things that we have to understand about the amplification. Okay, when we understand this one, now we can find a way to make sure things work. That's what engineer do lah. Engineer is, we as engineer, we need to know physics. We need to very fully understand how things works. Then we can design whatever things to make sure that everything's being designed properly lah. So that's engineer. So do not take for granted about physics and all the science things. Okay, chemical, biology, all things are related. I remember about the Tony Stark. Tony Stark, they are mechanical engineers, isn't it? They're building a lot of things, but he familiar about the physics. I think most of the mechanical engineers, they're very good in physics, usually. Okay, now we look at this filtration. Filtration have three main things. Physically or mechanically. But when I mention mechanical, it means about mechanics of air, mechanics of moving objects, mechanics of anything lah about mechanics. So mechanics is we can feel, we can see, we can observe. Okay, we use the mechanical to filter a lot of things. For example, my microphone, usually we have sponge. Okay, sponge. It's mechanically filter some noise from the background noise. We also can use, the next one is electric filter. Okay, after the sound come to microphone, of course it's combined with some sort of like electronics kan, because wireless kan. So wireless because we introduce some kind of electronics noise, and then that one can be filtered using electric filter lah. Okay. But pneumatic filter is actually pneumatic is if we have pneumatic system. Usually mechanical engineer, especially in automation they use pneumatic system. So pneumatic system is based on air. You're giving some sort of information from other sides, and the information transfer through the air and then go to someone else. For example, information is just like attenuation. Actuation. You actuate something and it will give to information to the other side. So the transmission is through the air. So the transmission through the air must have some sort of noise lah. Maybe fluctuation of the air, pressure different. So all these things need to have some kind of filter lah to make sure that everything flow very well. So that's to have a pneumatic filter lah. That one we're not gonna go very detail on that one. We focus on the first and the third one lah, mechanical and electric. Even we go to the third one, because like I said, you are automotive engineers. You basically go towards electronics kan, to electronics. Right. But for my study, I use light as a transmission. I think at the end of this semester, I think it's more interesting. I will use a few parts of the lab to show how optical fiber sensors work. I think this one can be used in maybe in the future for automotive light transmission. Because of what? Because of sensor. One sensor require one hardware. For example, one sensor it require one acquisition. So because of one sensor, the information from a sensor will be translated towards something that can be useful for the computer by using like a box. So one sensor, one box. If we have like 100 sensors, so you need to have 100 box, or maybe 4 sensors, one box. But 100 sensors cannot be one box lah. Maybe more box, which is increase a lot of cost for that one. But for the optical sensors, 100 sensors can only be used one DAQ, one data acquisition only. In fact, it can be used for 1,000 sensors, because light contain infinite numbers of wavelengths. It depends on how much we choose the wavelength lah. Okay, wavelength. In the wavelength, there's a lot of information can be transferred. So each sensors one information. So that's why they use Unify or use internet. They use optical because the optical have a lot of information can be transferred. So that's why maybe in the future, if the car need to have a lot of sensors around the car, maybe in the door itself there is a lot of sensors, kan? So maybe in the future they will use optical sensors. So I will not invest myself into studying conventional sensors. I invest myself to study future sensors. Mark that thing, put in your mind, study about futures, because who knows that in the future they will use your technology. Okay, this is just you can refer the one in the notes later on. Just the same thing that I explained. Okay. Okay. I think this is the same thing that I explained. Just read. Okay, sorry. Oh, this one different. Number 3, signal processing element. So for this one, I only put only one slide for this one because we're going to see later on using software. We have DaisyLab software. Usually DaisyLab software ni it just basically in when you do programming, you use MATLAB or you use whatever programming software, you need to put coding, isn't it? But I just want to reduce the work on doing programming into using module based programming lah. You just pick up module and then it's automatically can do your work. You don't have to write down your programming. We will see about this later, but we're gonna do that one later on in using software, how to do the signal processing. But the thing is, whatever signal when it get into the computer, you can do a lot of things. It's up to you, up to your creativity to do. Okay. All right. Now this is auto. These things, these things actually for me lah, through my experience, this one lah, showing whether your equipment is expensive or not. Display. If you get a very big display, you can say that this is expensive. Although the internal part is the same thing as the other sensors. I mean, people judge things by its looks. So if you have a good way how to present your system, it might give like impression to people that this is expensive, this is very good, this is very high quality. So we need to invest a lot of things on this one. That's why I said, I think last class I said, when I do sensors system, I put this one to the external person to do it for me. I mean professional one. They will do this presentation, the data presentation for me. Okay. So because I want to give the impression to the who want to buy my system, this is a very expensive system and good system. So it may be in terms of just simple indicator, okay, macam pembaris, the ruler, you have a scale, just as simple as that, or a thermometer, you have a scale and thermometer, as simple as that, or you need to have a visual display unit, electronics display like a tablet or screen, whatever lah. Okay, the only thing is this system must have fast response. It's showing the real time and real time lah. Make sure that it's real time. Sometimes when something happen, it will have lagging about 2-3 minutes that it will appear. If you don't have problem with that, it's okay. But sometimes some system need to have a real time measurement. For example, the earthquake measurement, then they need to have as fast as possible, because I mean half an hour or half minutes, you can do a lot of things in half minutes. Okay, before it receive the impact of the earthquake. So that thing is need to have a real time. So we need to have we spend a lot of time to make sure that the signal transfer from other parts is very quick. Very quick. If you're aware that what I'm saying is actually all these things require some sort of your logic lah, your logic. When you design things, you have to use your logic in terms of designing things, not only using calculation and so on. That is the innovation part lah, your creativity. So have a look on this. This is actually we go through this one by one lah, so that you can see what actually happening here. If you look at the first one, it's actually a temperature measurement system. You can see that we divide into 4 parts, which is first sensing, signal conditioning, and signal processing, and data presentation. So in sensing, we have sensors. This is the one that we study lah in this semester. And after that, we have signal conditioning. They use auto reference junction and amplifier. And then for signal processing, they use analog to digital conversion. Some people put analog to digital conversion in processing. Some people put it in conditioning. I don't know. I mean, it depends on the system lah. But for this one, it put analog to digital converter in signal processing part, computer, and video visual display unit as a presentation lah. So if you can see, all these things actually they put in the blocks, the same functional block. The same with the other one, which is the tacho generator. I mean the tachometer. Okay, the speed of the rotating equipment, and we have a signal conditioning, SMIC trigger, and we have the signal processing and display. And the same thing with the flow rate, and the same thing with the weight measurement. So we have sensing, signal conditioning, processing, and data presentation. If you look at the next one, so you have image over here. In details, we also can find they actually have the same elements. Sensor, signal conditioning. For this one, there's no computer involved, so only signal conditioning, and then straight away to the data presentation. Okay. So the conditioning parts actually amplification, isn't it? Amplification or filtering. For this one is amplification. So which part is actually try to amplify the signal? The gear, isn't it? So the ratio between gears, make sure that the signal either sensitive or can be amplified. So if you put gear to, let's say ratio, the tooth gear 1:1 with the gear. Okay, the tooth gear and the gearing to 1:1, so that is actually straight away. But if you put like gearing double compared to tooth sector, what happen is become amplified, isn't it? Amplified. One rotation equal to 2 rotation, so it amplified. But make sure that the needle, yeah, that one, make sure the small pressure comes in, the needle will move very fast, very quick, very in a big range. Okay, small input will give a large output. Okay, itu kalau kita ni. Tapi the problem is we sacrifice the resolution kan, dia move very quick, so we might miss some of small value. So that means there must be we need to design properly lah, make sure that we know actually what we want and what we need, what we have as an input and what we want as an output. So we need to have that one. Then we can design the system, the amplification. Either we need to ratio 3:1 or 2:1 or 1:1. And then display element, if you don't like the needle, you can use digital presentation. How you you convert into digital presentation? By putting electrical. Okay, instead of using gearing, okay, that Borden tube will move, will deform. Borden tube will deform, and they will give some kind of like this is actually a magnet voltage system. Okay, I think this one where do you study this one? I don't remember. Did you have study this one, this system? Not yet. frequently used in LVDT, linear variable differential transducer. Okay, but that one, when you move, when the bonding tube moves, it actually induces the motion to the magnet, and then it will move in the coil, and then it will generate voltage. Okay, you know, magnet when move in the coil, it will generate voltage around it. So that voltage increase linearly with the how much the magnet moves. Okay, so and then the bigger motions of the bonding tube, the bigger voltage that you can get lah. So now we see the voltage. Now it's very important. The voltage, either you use mechanical system to filter the voltage, or you use electrical filter in the computer. So the thing is, whenever you got the voltage, and then it's okay, it's good, because you can put into a lot of kind of displays, like digital display, simple digital meter, or you can display into computer as a big system. So this is actually the block. So we have a transistor element, signal condition element. Now still don't have processing, but it have external power. Okay, to power up the digital voltmeter. Okay, still don't have processing here, because the data presentation require electric. So it need to have external. This one we call auxiliary elements. Okay, still not involving the processing yet, because it's the value straight away from the bonding tube, from the pressure. Okay, pressure increase, it show the same value in the digital meter. The only thing is the digital side ni, it use electrical. Okay, but if you choose to put into computer, you cut that line, put into computer first, and then you visualize in VDU, visual display unit. The same thing with here. I think this one I let you to have a look later on. You see, study this one, and there's a lot of sensors that you can use for reference. For example, we have a temperature sensor. We need to understand what's output from what that we want. For example, temperature, the output can be in terms of voltage, in terms of displacement, resistance change, okay, the pressure. All this output require different sensor, require different signal conditioning, different signal processing. So we want to recognize the output form that we want. Okay. Right. When we recognize, we understand the output, what we want from the output of the sensor, and then we can design lah. We can design what kind of, for example, this one already have the suggested system sensor for this one. In fact, we're gonna go detail one by one after this, after half semester, after midterm. We go detail one by one. In fact, we're gonna use I'm gonna ask you to buy your own sensor later on. It can be bought easily in the eBay or Shopee. Murah je, RM2, RM1. Kalau RM2, how much in euro? how many? So very cheap lah. So what's actually I'm doing here, let me tell you a story. Let me tell a story about my experience in UMP. When I first developed my laboratory, what I do is I need to ask for procurement. I need to buy about for 4-channel system. 4-channel mean, when I say 4-channel, 4 sensors lah. It costs about 100,000 if I want to buy a complete system with 4-channel. But I mean, no, 100,000 is only for 2 channels, I think. If we have 4 channels, more than that. Now, after that, we study how to build our own system. So we study about the sensors, we study about the data acquisition and software, about the elements. We have 4 elements in it. We understand the elements. Now we know what we want to buy. So we study the EQ. Now we found out that we have a modular EQ from National Instrument. They're selling about, let's say, I think 10,000, 15,000 for 4 input. In fact, we have a cheaper one. I bought that one recently. I bought 30 units for us to study to do in the class. I think 1 unit is 1,500 ringgit, 1,500 ringgit. So total about 30,000 for. But now we know that actually 30,000 we can have 30 units. 30 unit with multiple input, multiple sensors. And then the software, how to view that one. Before this we have when we purchase system, it needs to come with the software by the vendor. They give together with the software, and that one costs about, let's say, 10,000, 20,000 about the software itself only. But now when we find a software like LabVIEW. I think you're familiar with LabVIEW. Maybe later on you study here, LabVIEW, or DasyLab, DASYLAB, DasyLab. Or we have a DasyLab here in our faculty. Now this software allow us to design our own system. It costs about 7,000 ringgit. I think 8,000 ringgit. I think the expensive, most important, is about 10,000, 12,000 ringgit full package. And you can operate multiple system. What I say multiple system is when I purchase one CD for that software, I can install in many computers without using dongle. I think the DasyLab manufacturer is very kind enough. Usually they give a dongle, isn't it? You buy a software, macam you play game, dulu kan game CD game. Now game tak ada lah. Dulu CD game kan. When you install CD, you need to put a key. So operate that one. For this time, the software you can install in every computer without any keys. You just input one keys lah. Okay. So the key is regardless any computer, you can use the same key. We found that one, and then we combine and then we combine the software. The only thing is we need to have sensors je lah. We need to find, but sensor is very cheap. Like I said, strain gauge about 1 ringgit, 2 ringgit. Piezoelectric sensors about 2-3 ringgit. So all these things, remember that I purchased about 100,000, almost that one, and then now the cost is a lot cheaper lah. So in fact I can sell my own system. So not me lah. I can teach you how to build your own system and sell your own system. Okay. So itulah the knowledge that we have here. Hopefully that give you something lah later on. Okay, so you go and have a look. I'm not going to detail about this one. I leave it to you because you have self-learning about 2-3 hours after this. Okay, I give you a lot of example for you to get the idea of all these things. The only things I want to show here is exercise. Okay. Okay, this exercise. Suppose that this exercise be the quiz, but never mind. Just we do exercise lah. Okay. If you look at this one, maybe we discuss. Okay. Which part is the sensing elements? What do you think? Remember the definition of sensor? It converts the physical motion into something that we can recognize. Apa dia? Apa yang kita nak measure? What we want to measure right now? Kita nak tengok liquid level. We want to see the liquid level. Actually the liquid level ni from physics, how can we measure liquid level in physics? Either we use a ruler lah. You can put there's a lot of things that we can do here actually. Forget about this picture. to measure liquid level, there's a lot of things we can do, creative way. But if you look at here, the liquid level, it depend on, is related to the weights. Okay, the more, remember, apa the question? MGH. The more level, the higher level of the water, it will give more weights. Okay. G, gravity is fixed. M, the mass, the density, rho GH, not MGH, rho GH. Sorry. Saying the wrong words. Rho GH. So rho is fixed to the water, and G is fixed, but you have H, so it will give the H value. So rho EH is equal to the force. Okay, force. So the force will give the motion to the diaphragm. Okay. Now you see, diaphragm will move with the force from the water. So what we do is we only need to sense the deformation of the diaphragm. Okay, how big the motion of the diaphragm. So now depends on you lah. What kind of sensor do you want to use to sense the diaphragm? For this one, he used a simple mechanical. Apa dia? Spring tu is it sensor or what? Spring. Is it spring involved in the measurement? No. What is the function of a spring? What's the function of a spring? To make sure it gives back to the position, earlier position lah. So if we remove the water, it will move back to the original position. So this the function of the spring. Doesn't reflect to anything about sensors lah. Okay. So okay, for your in your opinion, what is the sensor here? Which one? Which part? Diaphragm, isn't it? Diaphragm kan? So so we know that diaphragm being a sensor, what we can do to the diaphragm to make sure that it's sensitive, make it more elastic, isn't it? So you find the best diaphragm to make sure it's elastic. But if too elastic, what happen? Too sensitive. Maybe we need to have a very big room down under the tank, isn't it? So because it's too elastic, we need to have a lock. Even in fact, kalau too elastic, how about the safety? I think quite safety wise, I think it's quite dangerous. So all these things. So when we recognize which part is the sensors, and then we need to put our brain to make sure that everything is safe, and then we need to put all the efforts in terms of looking at the how good the sensitivity of the sensor lah. And now we recognize the sensor part, the sensing part. Now we move to the conditioning. Which one is conditioning part? No, we know that spring is not involved here. Okay, so is the level mechanism. So how to make sure that it's actually sensitive? Which part that we can change in the level mechanism? Fulcrum, isn't it? The position, the point, kan? If we move towards the scale, it will be more sensitive, isn't it? No, it less sensitive, isn't it? But it will give more resolution, kan? Kalau you move towards the joint, kalau kita move this one fulcrum towards the joint to give more motion to the scale. So now that's how we think. That's how we think, how we design. In fact, we're looking at this actually the already suggested system. Maybe you can find your own system. You design your own system. Okay. So the point is, I want you to understand which part is sensing part, which one is the conditioning part. So data presentation, of course, the scale lah. This is data presentation lah. Okay. Right. Now, Another quiz. Alright, so this one, same. Which one sensor? So first we need to find which apa dia ni? Ini ialah weight measurement system. Okay, weight measurement system. Okay, so we have a weight here. We have to measure how much the weight. So for this one, which one is sensor? Which one is sensor? I believe the sensor is the motion, isn't it? The motion of the... Which part is to sense the motion of the weight? Because the more the weight, it will give more deformation to the spring, isn't it? More weight give more deformation to the spring, so the spring will stretch further. So which one indicates the motion of springs? The spring itself, isn't it? The spring itself lah. I think this part here. This part there. That part will indicate how much the spring move further down or further up. Okay. And then, so that's one is sensor. And then what's the conditioning element? It's the other spring lah. The like this, the same as before. We have a fulcrum system. So that one can give the apa nama, signal conditioning lah. Okay, the next one, I think this one have in the previous exam but never mind this one. I leave it to you to see, find. Like I said, usually I give the quiz for this one, but not for today lah. Maybe I can give a quiz later on about other subject, maybe about calculation. This one just to make sure that you have a mindset how to design, how to recognize that 4 basic function tu. First is sensor element, signal conditioning element, signal processing element, and data presentation element. So throughout this exercise, hopefully that you get the idea lah. Now I think we have finished the first parts of the lecture, which is the basic element of the sensor system. Okay, so but with that I say thank you for those who come